Hey, our good alien friends are back. So it must be another situation where we're going to have 6 pieces of a triangle, 3 sides and 3 angles. And today we're going to be looking at the law of cosines. So again, if we're lucky it's a right triangle, that really speeds things up. If it's not a right triangle, but I have an angle with a corresponding side, I can use the law of sines. But if things get desperate, then we got to go to the law of cosines. Now again, angle C is not a right angle. Side C is not a hypotenuse. This is just a generic arbitrary triangle. Now there's actually 3 forms of the equation because it depends on if I'm looking for side A or angle A, or if I'm looking for side B or angle B, or if I'm looking for side C or angle C. Right, if I want side A or angle A, I would use that top equation. If I want side B or angle B, I use that middle equation. If I want side C or angle C, I'm using that bottom equation. Okay. Hey, I know 114 degrees is angle A, but I don't know the corresponding side. And that's the only angle I know. So law of sines will not work. Right? This is an angle side angle. What should we find first? Well, we know capital A, we know lowercase b, we know lowercase c. So we got to go find A. All right? Because that way I've got an equation where the only value I don't know is lowercase a. I know lowercase b, I know lowercase c, I know capital A. If I tried to use one of the other forms of the equation, I would have 2 unknown values. I can't solve the equation if there's more than one unknown value. So b squared becomes 23 squared, c squared becomes 26 squared, 2 times b times c becomes 2 times 23 times 26. Finally, cosine of A becomes cosine of 114. Well, with a calculator, I can figure out 23 squared, I can figure out 26 squared, I can figure out 2 times 23 times 26. But even though I'm using a calculator, notice I'm still writing the numbers down on paper. I still need to show step-by-step algebra. course, 529 plus 676. Could do it with pencil and paper if I needed to, but calculator is probably easier. Now, here comes the silly part. A lot of students will try to take that 1,205 and they'll try to subtract 1,196. Can't do that. Remember, I have to do any multiplying or dividing before any adding or subtracting. So I've got to figure out the value of cosine of 114, and then I have to do my multiplying. Of course, negative times negative comes out positive. And then I can add those together. And then, of course, I can take the square root. And again, even though I'm using the calculator, I'm going to show on paper step by step what these values are and where they're coming from. So I now know that side A is about 41.1. Now, if anyone is really paying attention out there, you're probably scratching your head and going, how is that possible? Right? We'll come back to that. If you didn't notice anything weird, don't worry about it. If you did notice something weird, we'll talk about it in a minute. But hey, I now know angle A and side A, so I no longer have to use the law of cosines. I can switch over to the law of sines. Right? I can compare sine of B to 23. I can compare sine of 114 degrees to 41.1. Multiply both sides by 23. I'm going to grab a calculator. Now, when you get comfortable with the calculator, notice what I just did there. Instead of doing each piece individually, I actually typed in 23 times sine of 114 divided by 41.1. Notice I was very careful to make sure that 114 is inside parentheses. If you're not that comfortable with a calculator, you might go one step at a time. 0.5, that can't be right. Oh my goodness, I don't want sine of B, do I? I want B. Right, so every time I get an answer for an angle, I'm like, hey, this doesn't look anything like what it should be. I got to ask myself, hey, did I remember that last step? Did I remember to use the inverse sine function? And so the actual angle is much closer to 30 degrees, about 30.7. Now, of course, that's a triangle, and I know two angles. I'm on easy street. I know they have to add up to 180. I can push buttons on a calculator pretty quick, but please still show on paper what you were doing. Here's what happened the previous slide that should have probably caught you off guard. You're like, no, wait a minute here. How did cosine come out with a negative value? Well, we're not doing SOHCAHTOA. I don't have a right angle. Right? On a right triangle, we never have an angle larger than 90 degrees. So the adjacent side is also a positive number. The hypotenuse is also a positive number. Adjacent over hypotenuse is always going to be a positive number. Right? But we're not working with a right triangle. We don't have a leg. We don't have a hypotenuse. And if you're wondering how we could possibly get a negative ratio, well, come back in 2 years. Right? Not Algebra 2. That's next year. The following year, pre-calculus. And then you'll figure out why cosine of any angle greater than 90 has to be negative. And thank goodness it is, because it's going to save us in just a few moments. Hey, it looks like side, side, side this time. We don't know any angles. All right, we've got a side, side, side here. So what should we find first? Well, it's very, very obvious what I would recommend finding first. Angle B. Now you're probably thinking, now wait a minute. Why can't we start with angle A? Why can't we start with angle C? Why do you want us to start with angle B? Why indeed? It might be a little bit before we get this example started. All right. Look at the sine of 89. 0.999 blah, 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 blah. Look at the sine of 91. 0.999 blah, 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 blah. If I'm 1 degree short of 90 or 1 degree more than 90, the sine ratio is identical. Cosine of 89, about 0.017, blah, 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 blah. Cosine of 91, negative. It's negative 0.017, blah, 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 blah. So if cosine is 1 degree short of 90, it's not the same as cosine of 1 degree greater than 90. The sign has switched from positive to negative. That's the problem with the sine function. When we get close to 90 degrees, using the law of sines, we can't really tell if we're more than 90 or less than 90. Right? So with the very largest angle, because the largest angle in the triangle could be greater than 90, the law of sines will fail if we're trying to find that angle. The law of cosines will never fail us. If the angle happens to be more than 90, cosine will come to the rescue. Now, of course, when we have a right triangle, it's not an issue because we already know the largest angle is exactly 90. And then we can do SOHCAHTOA because everything's smaller than 90 that's left over. But when we just have an unknown triangle where we don't really have any clue what any of the angles are, because the largest angle might be more than 90, I want to find that first, and I want to use the law of cosines to find it first. Right? If I tried to use the law of sines to get the largest angle, that won't work. Now, if the largest angle is more than 90 and I already know it, I can use law of sines. Or I can use the law of sines if I find the largest angle at the end by making the three angles add up to 180. But if I'm going on a treasure hunt and I don't know what I'm going to find, go for the largest angle first and use the law of cosines. All right, so with the triangle we have here, since the largest side is 6, and that's across from angle B will be the largest angle. And I don't know if it's going to be more than 90 or less than 90. So I want to use the law of cosines to take that one out first. Because after I use the law of cosines one time, I'm going to switch to the law of sines to make life a little bit shorter and easier. Okay, so since I want angle B, this is the equation I have to use. B squared equals A squared plus C squared minus 2AC cosine B. Lowercase b, of course, is 6. Lowercase a is 4. Lowercase c is 5. 2 times a times c becomes 2 times 4 times 5. Cosine of b, well, I'm stuck with cosine of b. I don't know what b is. 6 times 6, of course, is 36. 4 times 4 is 16. 5 times 5 is 25. 2 times 4 times 5 is 40. Of course, 16 plus 25 is 41. Silly mistake. A lot of students will do 41, take away 40, and they'll come up with 1. You can't do that. Those are not like terms. You've got a plain old 41 that cannot combine with a 40 times cosine of b. Instead, I've got to subtract 41 from each side. So I've got -5 equals -40 cosine b. Divide each side by -40. And I've got a positive 0.125. Now, I know that angle B is less than 90 degrees because 0.125 is positive. So I know when I do the inverse cosine, I'm going to actually get a value less than 90 because inverse cosine is always going to convert that way, right? If we're more than 90, cosine comes up with a negative value. If we're less than 90, cosine comes up with a positive value. So if I start with a positive and do inverse cosine, I know that the value will be less than 90. So that is the largest angle. I know the other angles must be less than that. It's obviously safe to use the law of sines for the other angles. I could go for A or C next. I just happen to pick A because it alphabetically comes first. So I set up the law of sines, multiply both sides by 4. And again, I want to do all of this algebra before I touch a calculator. Right? Up to that point, I've not done any calculator work. Now I can grab a calculator, figure out that sine of A is about 0.6614. So angle A will be the inverse sine, about 41.4. And of course, if I know two angles, the easiest way of going about this is make them add up to 180. Sure enough, C is about 55.8. Huh. What should we do first? That's right. If I'm just given a list of values, I'm kind of stuck if I don't have that picture. So once again, it's side, side, side. I've got to use the law of cosines. I can't use SOHCAHTOA because I don't have a right triangle. I can't use the law of sines because I don't know an angle across from its corresponding side. I have to use the law of cosines. And so I will start with the largest angle because I don't know if the largest angle is greater than 90 degrees or not. Since 11 is the largest side, I know angle B is the largest angle. That's what I want to find first. So after I write down b squared equals a squared plus c squared minus 2ac cosine b, I then substitute the values I know. Of course, 11 times 11 is 121, 6 times 6 is 36, 7 times 7 is 49, 2 times 6 times 7 is 84. Now, don't get silly and just start adding and subtracting numbers like crazy. I can add the 36 plus the 49 together because those are like terms. I cannot do 85 subtract 84. Those are not like terms. The 84 has a cosine of b hanging onto it. Right? The 85 does not have a cosine of b hanging onto it. I cannot combine those. Instead, I need to subtract 85 from each side. Of course, now I can divide both sides by -84. Aha! We have a negative value. So before I grab a calculator, I know I will get an angle greater than 90 degrees. Because if it's less than 90, cosine is positive. If it's more than 90, cosine is negative. So I know when I do the inverse cosine function, if I'm starting with a negative number, my angle will be more than 90. Holy cow, that's a lot more than 90. 115.4. Now, even though that angle is more than 90, it's safe to use the law of sines because I'm not trying to find it. Right? I'm trying to find the angles that are less than 90. So the law of sines is perfectly safe to use now. Because angle A is less than 90, right? Because a triangle either has 3 acute angles, or it has 2 acute angles and 1 right angle, or it has 2 acute angles and 1 obtuse angle. Right? If we're in Euclidean geometry, a triangle must have at least 2 acute angles. Again, that's a lot of step-by-step algebra I need to show on my paper. I don't just want to see that 29.5 magically appear. I need to know the proportion that was set up. I need to see the values substituted in. I need to see how sine of A got isolated. And then finally, I need to see how we go from sine of A to just A. Of course, anytime I know 2 angles in a triangle, the easiest way of finding that third angle, they've got to add up to 180. Again, I know I'm going to push buttons on a calculator, but please show on paper that you understand those 3 angles have to add up to 180. Then I'll understand where that 35.1 is coming from. Again, very few questions on today's worksheet. Please make sure you show glorious, wonderful, beautiful, fantastic step-by-step work. And then with extra time, if we have time available, IXL has some excellent practice with the law of cosines.